Hello. This video is for textbook lesson, chapter 1 and lesson 7. That lesson is titled Multiplying and Dividing Integers, where our objective is that you will, well, just what the title says, we're going to multiply and divide integers. Our vocabulary here, and they do say it's review vocabulary, so apparently you've come across this word before, but the word is mean. We'll get to that later in the lesson. So it starts off with this stock market example. It says you own shares of stock in a computer company and in a utility. The value of the shares changes over time. The table shows the number of shares of each type of stock you own and the change in the value of each share over a 1-year period. What is the total change in the value of your shares of stock? So we have a table here, and our first column is the stocks that we have. They are computer and utility. The second column is the number of shares that we have, which is 200 of the computer and 100 of the utility. And then the third column shows the change in value of one share. So for each of these 200 shares over 1 year, each of those shares decreased by $3. And for the utility, 150 shares, each of those shares increased by $2. So in example 2, we will see how to multiply integers to answer the question that we're given here at the beginning, referring to our stock market question. So first we're going to look at something else before we get to the solution for that, and that is the idea of multiplying and dividing integers, what we need to know in order to be able to solve that question that they're asking. So in the activity on page 41, you may have recognized patterns in the product of integers. These patterns suggest the following rules. So let's go back and look at that activity that was on page 41. And this is the activity that is found on page 41. And we start off with a table in which we have an expression in one column and the product in the other. Product is the result of multiplying two numbers together. Let's say we have 4 times 2, and that equals 8. This here is the product. Okay, product. There we go. And the items that are being multiplied together, such as the 4 and the 2, these are known as factors. So we multiply factors together to get products. All right? So multiply factors to get products. So in this table, we have expressions with some factors in them, and then we have a column for the product of those factors. So they give us the first 3. 3 times 3 is 9. 3 times 2 is 6. 3 times 1 is 3. And 3 times 0, well, we know everything. Anything times 0 is equal to 0. And if we follow the pattern here, the first factor is always 3s. And then the second factor, notice we're counting down. 3, 2, 1, 0, -1, -2. Well, if we follow that pattern in the products, we would have 9, 6, 3, 0. And if we kept going, we would get -3 and -6. And we'll look at this pattern here, what we might be able to imply from it in a moment, but let's look over here at table number 2. Here we have an expression to where the second factor is -3, and the first factor, we're counting down once again. 2, 1, 0, -1, -2, -3. So we have over here, let's see, can we look at no, we don't have any of the same ones over here. I was looking to see, do we have any over in the table that are the same? No, we don't. But we do know that this is going to be 0. And if we think of 1 times -3, you owe one person $3. So you would owe how much total? Well, you'd owe $3. And if you owed 2 people $3 each, you would owe $6. So let's follow the pattern now going down the table and see what we might be able to find out. So -6, -3, 0. Well, if we kept counting, looks like we're counting up by 3s, we'd end up with 3, then 6, then 9. And what we can tell from this table is that if we have a positive, I'll use a plus sign for a positive. Positive times a positive equals a positive. We see that here, here, and here. Anything times 0 is going to equal 0. Here, if we have a positive times a negative, then it's going to equal, apparently, a negative. And here we also have positive times negative is equals a negative. Over at this other table, we have a positive times a negative equals a negative. So that's the same as what we had over here. Positive factor times negative factor. And we could have used that concept there going from here to here, right? Again, we have anything times 0 is equal to 0. And here we have a negative times negative equals a positive, and negative times negative equals positive. And then finally, the last one is also negative times negative equals a positive. So we're coming up with some rules here. And one thing that we didn't see in here, we see positive, 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 negative, positive, negative, negative, negative. One thing we didn't see was, well, what about negative 3 times positive 2? What would that equal? Well, this is a negative times a positive. We really haven't seen that here. We got positive times negatives. But one thing we know is that 3 times 2 equals 6, and 2 times 3 equals 6. So that means that we could actually reverse the order. That's called the commutative property of multiplication. We could reverse the order of the 3 and 2, and it doesn't make a difference. So we could say that the positive 2 times the negative 3, that's going to equal negative 6 as well. They both equal negative 6. So apparently a positive times a negative equals a negative, and a negative times a positive equals a negative as well. So from all of this, we come up with a rule, and we see that rule here in our notes, multiplying integers. In words, we say that the product, remember product is the result of adding two factors together, or multiplying two factors together. The product of two integers with the same sign is positive. So positive times positive equals positive. Negative times negative equals positive. So if the signs are the same, here we have same signs, here we have the same signs, and they both come up positive. The product of two integers with different signs is negative. So we have a positive times a negative equals a negative, and a negative times a positive equals a negative. So same sign, it's always going to be positive. So two positives make a positive, two negatives make a positive. And if they're different signs, such as a positive and a negative, or a negative and a positive, the answer is going to be negative. And then finally, of course, what we probably knew already is that the product of any integer and 0 is going to be 0, such as 2 times 0 is 0, or negative 2 times 0 is 0. So whether it's positive or negative, we multiply times a 0, the product's still going to be 0. Now, if that's not quite if you're still having a little bit of difficulty with that, years ago I used to teach this little memory device here. You can make a triangle, and you could actually cut a triangle out if you would like. And if you put a negative sign in one corner, a plus sign in another corner, and then a negative sign in the other corner, then you can use this as a memory device. And why this works as a memory device is, well, we already know you've been doing positive times a positive for years, and you know that positive times positive equals positive. But if you multiply negative times a negative, and you would take your fingers and cover the negative corners, and so if we took out negative times negative, that leaves us with a positive answer. And if we took a positive or a negative times a positive, so negative times positive, cover those up, and you would see your answer is going to be negative. And if you took a positive times a negative, so if you were to cover the positive and negative up, you'd see that you would have a negative left. So if this over here, the rules that we see in this table become kind of confusing and you're not sure, you could always make you one of these triangles, and that would help you out. So in example 1, we see that negative times negative, negative 3 times negative 12 is going to be positive 36 because they are the same sign, so the answer is positive. And here we have negative times negative. That's going to be a negative 63. They are different signs, so the product is going to be negative. Same sign, positive. Different signs, negative. And then, of course, we have the whole thing about the product of any integer, and 0 is going to be 0. So here's our stock market question that we had from our first page. And looking back at the math portion for this problem, we see that in order to find the total change, that we have to take our computer shares and multiply them times the change in each of those shares. And if we look back and see 200 computer shares, and you remember that they decreased by $3. So in our setup of our math problem, we have that as a negative 3. And then we had 150 utility shares here. And remember, the utility shares had an increase of $2. So we're going to call decrease minus 3 and increase plus 2. So back to the math problem we go. And we see in that setup, sure enough, with the computer shares, we have negative 3. That is down $3 for each of the 1 shares. And then for the utility shares, we have an increase of $2 because each of the utility shares went up. So now we need to multiply the 200 times negative 3, positive times negative. They're different signs, so the answer is going to be negative. We see that right here, right? And 200 times 3 is going to be 600, so that's negative 600. And then 150 times 2, they're both positive. So they're both the same sign. The answer is going to be positive. And we see that here with the plus 300 because 150 times 2 is 300. Now we need to go ahead and add negative 600 and 300. So we realize they're different signs. Go back to the rules for adding integers. They are different signs. 600 has the greater absolute value, so 600 is negative, so that means that our answer is going to be negative as well. And that since they are different signs, we need to subtract instead of add. 600 minus 300 is 300, so we end up with an answer of negative 300. So the total change in value was negative 300. The value of the stocks decreased by $300. The negative 300 represents a change of a decrease of $300. All right, so moving along, let's talk about dividing integers. Well, we've talked about multiplying, so let's see, is there a rule for dividing them? Well, because 3 times negative 4 equals negative 12, different signs, right? And so they're positive, that's negative. You know that negative 12 divided by 3 equals negative 4, and negative 12 divided by negative 4 equals positive 3. So let's go back a little bit and think of something simpler, not dealing with negatives. We know that 2 times 3 equals 6. So if we take the product of two factors and divide it by either one of those factors, in this case we'll say the 2, then we know that the answer is going to be that other factor. 6 divided by 2 is 3. Or if I took that 6 and divided it by the factor 3 that we have here, then our answer would be the other factor that was multiplied times that 3 to get that product of 6 in the first place. So that answer would be 2. So we know that if we take the answer of a multiplication problem, which is the product, and divide it by either of the factors, the answer is going to be the other factor. So what they're saying in this particular description here is that if 3 times negative 4 equals 12, actually negative 12, then we know that if we take negative 12 and divide it by either one of these, say the 3, we're going to get the other factor, which is negative 4. And if we took the negative 12 and divided it by the negative 4, then we would get the other factor of positive 3. So what this leads to is the idea that we already know if we take a positive like 6 and divide it by a positive like 3, that we're going to get a positive answer, such as 2. So we know that positive divided by positive is going to equal positive. But over here, if we take a positive or a negative, divide it by a positive, such as what we see right here, I'm doing this one here, that's going to equal a negative. And then looking at this example here, we know that if we take a negative and divide it by a negative, that it's going to equal a positive. So we end up with the same situation. That is the quotient. In this case, the quotient is what you get from dividing two numbers. And the quotient of two integers with the same sign is positive. So again, same sign, positive. So positive 8, positive 4, positive 2. Negative 8, negative 4, positive 2. Same signs, right? And it produces a positive result. Now, the quotient of two integers with different signs, that's negative. So here we have a negative and a positive, and that's producing a negative result. Here we have a positive divided by a negative, and that's producing a negative result. So different signs, negative, same signs, positive. And then, of course, the quotient of 0 and any non-zero integer is 0. So 0 divided by any number is going to be 0, just like 0 times any number is going to be 0 as well. So let's look at some examples here. We have negative 48 divided by negative 6. They're both negative, so the answer is positive. And 48 divided by 6 is 8. 56 divided by negative 8. Well, 56 divided by 8 is 7. The question is, should it be positive or negative? Well, this is positive, that's negative, so they are different signs, so the answer is going to be negative. And then finally, 0 divided by 9. 0 divided by any number is going to be 0. So let's do some of our checkpoint stuff here. It looks like the 1 through 4 is all multiplication, and it looks like 5 through 8 is all division. So we'll pick a couple of those out. Let's do number 2. So I have a negative times a negative, so they're the same sign, so it's going to be positive, right? It's going to equal positive. And 6 times 8, so for problem number 2, negative 6 times negative 8 is going to be a positive 48. Looking over here, that was negative, negative. Let's look at number 3, right? 3 is 0 times negative 100. Well, 0 times anything is, that's right, it's 0. And I'm going to go back to number 1 here. I already did a negative times negative with number 2, so let's look at a positive times negative. So for problem number 1, positive times negative is going to be negative, and 9 times 11 is 99, so negative 99. Looking at, what about number 6? That one should be easy, right? 0 divided by, well, any number is going to be 0. And here we have a number 7. Negative divided by a negative, it's going to be positive. So we know that they are the same sign. So the answer is going to be positive. And 35 divided by 7 is 5. And then finally, number 8. The two signs are different, positive and negative. So the answer is going to be negative. So for number 8, I know my answer is going to be negative. And 24 divided by 6 is 4. So the answer, or the quotient to be exact, since it's division, the quotient is negative 4. On example number 4, we get to our vocabulary word of what is a mean, right? And for many people, this is a word, the word that they use for it is average. They say, what's the average cost, or what's the average temperature? In this case, they're talking about temperatures. So a lot of times people think of this as average. What is the average? But there are several types of averages. You may have heard of mean, which is what we're going to do here, median, mode, and range. Well, all of these are what we call measures of central tendency. They're all averages of some sort, but the most common one that whenever people say average, they usually mean the mean. And this is the one that usually takes the most work. Median and mode and range don't seem to take as much work to calculate as the mean does. So I always teach it as, since it takes the most work to do it, it's mean. It makes you do more work. So, gee, isn't that mean? You've got to do more work to find the answer. So that's my memory device for it. But in order to find the mean, you have to add a bunch of values up and then divide by the number of values that you added up. So Antarctic temperatures. The table shows record low monthly temperatures from June to November at McMurdo Station in Antarctica. Find the mean of the temperature. So they want to know, what many people think of as the average. So to find the mean, we have to add a bunch of numbers up and then divide them by however many there were. So our solution is to find the mean of the temperatures. First add the temperatures, then divide by 6, which is the number of temperatures that we added. So we'll see here that we take the negative 42, negative 59. Let's highlight those. Negative 42, negative 59, negative 57, negative 47, negative 40, and negative 19. We're going to divide, and the reason it's a fraction here is that's a really long fraction, all right? A whole lot of stuff in the numerator there. A whole lot of add-ins that we have to add together. But every fraction is a division problem, so this is the sum of all these numbers divided by, we read the fraction bar, we could say divided by, and then 6. So the reason we're using 6 is because 1, 2, 3, 4, 5, 6, there are 6 values that we added together up here in the numerator to get a sum of negative 264. Now we're going to divide that by 6. The thing that we're looking at here, why does this match the lesson? Because we are dividing integers, and the numerator is negative. The denominator is positive, so they have different signs. So the result is going to be negative. So negative divided by positive is negative. And 264 divided by 6 is 44. So the mean of the temperatures is negative 44 degrees Fahrenheit. So that takes us to our guided practice section. And vocabulary check, explain what the mean of a data set is. Well, the mean is all of the data added together and then divided by the number of data points that we have in the set, just like we did here with this. We added all these data points together to get a sum, and then we divided by the number of data points to get the mean of that data set. So next one, if a and b are integers and the expression ab is positive, what do you know about the signs of a and b? Well, we know that if the signs are the same, then the result is positive. So either both a and b are positive or both a and b are negative. That's what we can tell. Knowing that the product of a and b is positive, we know that they are indeed the same sign. We don't necessarily know if they're both positive or if they're both negative, but we do know that they are indeed the same sign. Here, tell whether the product or quotient is positive or negative, so we don't have to calculate it. We just have to tell whether they're positive or negative. So here we have a multiplication problem with 2 factors. Both the factors are negative, so that means same sign. The product would be positive. Here we have a division problem. So we have a positive number divided by a negative number. They are different signs, so the quotient is going to be negative because they are different signs. Number 5, we have multiplication of a positive number times a negative number. Different signs, so the answer is going to be, yes, negative. Number 6, we have a division problem. Remember, all fractions are division problems. So we have a negative divided by a negative. They are the same sign, so the quotient is going to be positive. Different signs, negative, same signs, positive. So that's pretty much it for lesson 7 of chapter 1. It was multiplying and dividing integers, where we learned to multiply and divide integers. The key thing here is to remember from this slide here that if they are the same sign, then it's positive, If they're different signs, then the answer is negative. And that goes for division as well. Same sign, positive, different signs, negative. All right, so hopefully this helps you with your upcoming activities for this lesson. Good luck.